Today, we discuss cloud computing related issue. First, I give briefly introduction to what is cloud computing. It includes introduction, architecture, characteristics, service models, deployment models. Cloud computing has been widely used today. You can think about a lot of examples we use today. For example, we use the Gmail, right? In NT, Gmail, in fact, is the email. So this really be stored in the cloud. We have the house security system, right? Even for the doorbell, we call Ring, you can list hundreds applications where we use cloud computing. Cloud computing is an emerging technology. It is internet-based computing. So in cloud computing, we share resource, software, storage, information. These are provided to computers and other service demand. Cloud computing is a paradigm in which a system utilizes the virtualized resource of network of computer. So that's instead of local computers to handle a system workload. This network of computers handle data storage, hardware, and software demands, therefore relieving the workload and increasing the efficiency of the local computer. For example, in the, let's say 10 years before, NT has our own server. All the interactive, we deal with the NT server. Sometimes, probably the server is super busy. Sometimes the server does not have that much thing to do. The server just idle there. So in some way, computer not 100% be used. In today, all the information and the service requirement will be shared by the cloud computing. Therefore, if one server is super busy, other server can share the workload. That's a very, very brief sentence talk about that. So this picture shows us very briefly cloud computer concept. So you can look at here, this is us, client, right? We have client, then we need to have internet network. Then they have database or data storage system. They have many, many servers. That's briefly cloud computing consists of these few parts. So a cloud computing system is made of network of computers that utilize virtualized resource in order to better handle workload. Virtualized resource means you can use different server through the cloud computing. Let's look at a simple cloud computing architecture. It consists of three main components: client computer, distributed server, data center. This is another way to draw the cloud computing architecture, right? From here, you can see client computers, this us is user, right? You can have the laptop, you even can use the cell phone to log in to use the resource of the cloud computer. The second is distributed center. That's the service provided by these distributed servers. So you through the internet, you have huge data center now. The data center store all the related information. For virtualization, virtualization is a technique a complete installation on one computer runs on another. So the purpose is we can share a computer system among many users. It can isolate users from each other and from control program. Emulating hardware on other machine, that's the full virtualization. Let's look at a typical architecture that is the Amazon Elastic Computer Cloud. I'm sure a lot of students know this or use this cloud computing. So Amazon EC2 is a web service. It provides the following functions. It is provide resizable compute capacity in the cloud. What means resizable? Means if you, let's say I need one CPU, right? You can ask a cloud computer system provide one CPU, but suddenly my job gets larger, I need 100 CPU. Cloud computing can in a few seconds provide you use a few hundred CPU. It is designed to make web scaled computing easier for developer. Provide web service interface allows the user to obtain and configure capacity. If you use cloud computing before, you can easily understand this sentence. You log in the one, let's say IBM cloud computing. They have one interface that you ask what kind of software, how big capacity hardware you want, you configure that. That's what this sentence means. Provide the user with complete control of their computing resource and let them run on Amazon proven computing environment. Provide the developer the tool to build a failure resilient application and isolate themselves from common failure scenario. So that's another way. If you have problem, the system can quickly get resource from another location, let you continue the work you are doing. So benefit, reduce the time required to obtain and boot new server instance to minutes very quickly. Allow users to quickly scale capacity. We just mentioned before, both up and down as their computing requirement change. That's the big benefit for the cloud computing. Change the economics of computing by allowing the user to pay only for capacity they actually used. In other words, you don't need to hire the people maintenance the system, right? Keep a certain capacity. Based on what you need, we mentioned here that calculate the time resource you used, then charge you how much you need to pay. So in the cloud computing system conference I attended, they have one equation, actually very complicated. At that time, it's a PhD thesis to calculate how much you need to pay, how many memory use, how many CPU use, blah, blah. You can think about anything you used. Then they give you the result, how much, plus how many time, the time period you use, they charge you. According to that student thesis, it looks like it's much cheaper, but I didn't do this side research. This is the briefly architecture of Amazon Elastic Computer Cloud. From here, you can see three parts. One, Amazon Web Services. Second, as a last student asked, cast iron system, right? This is the function of resource called premise application that provide. So let's look at each individual section, what kind of function that can provide, right? In the web service, a collection of remote computing service that together make up a cloud computing platform offered over the internet by Amazon.com. So that's the login place. The most central and very known of this service are Amazon EC2 and S3. Yeah, my personal familiar is Amazon EC2. What function cast iron provide? So it enables customers to rapidly complete application-specific integration use a configuration. Actually, it's an interface, not a coding approach. As a computer science student, everybody knows the interface, right? You can be graphic interface, you can normal interface, whatever. This specific interface provide the configuration picture there. You key in what you want, how much, like memory space we mentioned before. By using a pre-configured template, enterprises complete business critical projects in days. So you don't need to spend a lot of time. You just use that system interface, ask the resource you want. Okay, the last piece, right? On the premise CRM. CRM stands for Customer Relationship Management, also known as the licensed on-site or in-house CRM. It is a customer relationship management application that is hosted at a client location and managed by its own employee. Internal IT personnel are responsible for install all hardware and software components, integrating the solution with the existing system, deploying it to end user, and store all related data. That's the big part of the cloud computing system. This is just briefly what Amazon EC2 looks like. Is the typically cloud computing architecture. Now let's discuss the main characteristics of cloud computing. Normally, people list 5 main characteristics. The first one is on-demand self-service. What that means? That means a customer can unilaterally provision computing capability, such as server time, network storage, as needed automatically without requiring human interaction with each service provider. So like we just mentioned before, you use the configure, that interface submit your requirement. Then the cloud side will automatically do that. Broad network access has capability that are available over the network and access through standard mechanisms that promote use by heterogeneous, thin or thick client platform. In other words, you can use the laptop, you can use the cell phone, or you can use very powerful computer. In the cloud side, they don't care. You configure, you log in, you do it. The third one is very, very important characteristic called the resource pooling. Give the providers computing resource which are pooled to serve multiple consumers using a multi-tenant model with different physical and virtual resources dynamically assign and reassign according to customer demand. That's very important. Assign and reassign means you can ask, let's say I want the 5 CPU. After I finish a certain calculation, I say I only need 1. That's you can release that 4 immediately. There is a sense of location independency in that the customer generally has no control or knowledge over the exact location of the provided resource, but may be able to specify location at a high level of abstraction. So in this example, when we use like IBM, Amazon in general, you don't know your data will be stored in Raleigh, in the Minnesota, you have no control in general. According to my experience, when you log in the cloud computing, they're really random, sent to the location. In here, bring a big research topic for a few years already. The question is, normally we know when we have certain file after a certain time, or we think it is important, we delete it. In the old day, we store the file into the ANT server. When we delete, that data guaranteed be deleted. Now, because you don't know where your data is, even you delete the file, still not a guarantee all the copy of your file will be deleted. This is still the research topic. Like an example of resources include storage, processing, memory, network bandwidth, and the virtual machine. Okay, the fourth is rapidity elasticity, can be rapidly and elastically provisioned. In some cases, automatically to quickly scale out and rapidly release to quickly scale in. Still talk about the resource you use. To the customer, the capabilities available for provision often appear to be unlimited and can be purchased in any quantity at any time. That's the big beauty of computing, cloud computing. You can ask the resources anytime. Virtually, it is unlimited. You can ask as many as you want, right? Also, you can use it at any time. Because we talk about the security, before cloud computing born, right? The overflow is the big security issue. You over the capacity computer server can provide that, therefore you create an overflow. But now, after cloud computing born, you very rare hear that, because if one server is too much request server, that can quickly give to another server automatically. So therefore, data can attack dramatically be reduced. Managed service demonstrate cloud system automatically control and optimize resource used by leveraging a metering capability at some level of abstraction appropriate to the type of server. For example, storage, processing, bandwidth, and active user account. Resource usage can be monitored, controlled, and reported, providing transparency for both the provider and the consumer of the utilized service. These are 5 major characteristics. If you read the research article, that probably mention more than 5, but at least the 5 main characteristics here. We talk about cloud computing. It has been widely used. What benefit it can provide? The cloud provides users with a great deal of power and storage at a reduced cost, while allowing for easy and available access to applications running within the cloud computing. These applications can be accessed at any time and from anywhere. Therefore, it increases mobility for its users. In-house resources can avoid being underutilized and overutilized because the cloud infrastructure can be scaled on demand within minutes or even seconds. Others, mobility, internet centricity, resource optimization, pay per use, reduce cost, and high automation, you can list more in the others. This is the main benefit come from cloud computing. Now, we mention a very, very important topic. It's the service models. There are three main cloud computing service models. Some students probably know already. One called the software as a service. Normally you see SaaS. Platform as service, PaaS. Infrastructure as a service, IaaS, right? When we use cloud as a customer, most of us really deal with this software service. So we will discuss the detailed difference among these three different services. Regardless of the scenario, all software applications in the cloud are accessed through a thin cloud interface, such as a standard web browser. Actually, it doesn't matter you use the thin or the thick, doesn't matter that much for the cloud computing. This diagram gives the little more detail. Let us can easily see the main difference from software as a service, platform as a service, infrastructure as a service, right? In the following PowerPoint, I explain the more detail. From picture, you can see here. If we talk about infrastructure service, looks like you use much less the software, architecture, computer hardware in the cloud infrastructure as a service. If we go to one level up, platform as a service, you can see under the infrastructure service part, right? We add platform as service, means we add more. In general, they are software, but maybe sometimes you involve hardware. So if we look at this picture, software as a service, it is really based on infrastructure as service, platform as service, plus software service. That's the way they draw it. So in other words, as the most cloud computing user like me, we really is work on this level, software as a service. So now let's look at a little more detail. What that means. Software as a service use the provider's applications running on a cloud infrastructure and accessible from various client devices through a thin client interface, such as web browser. That's the very general sentence. The following give a little bit detail what you don't do, right? The customer does not manage or control, the underlying cloud infrastructure, network, servers, operating system, storage, or even individual application capabilities, with the possible exception of limited user-specific application configuration setting. In other words, when we, as a customer, use the software service, we use the previous mentioned configuration interface, ask what we need. You really do not involve the detail. For example, okay, I want to build a virtual robotic lab. I go to that configuration page. I can say, okay, I want a virtual lab, let's say 12 meter times 20 meter large. I want one robot with 5 sensors to measure distance, avoid the object. I need a robot to control the software to find the path in this virtual lab. all I require belong to application. I do not involve any, I change your operating system, I want to store in the Rally, blah, blah, blah. That's the software as service. Briefly, my explanation. The second is platform as service. Deploy onto the cloud infrastructure custom created applications using programming language and tool supported by the provider. For example, Java, Python, .NET, right? We know all this is the program language. Java, Python, right? Prescript language. .NET is the service environment. What the custom does not do, custom does not manage or control the underlying cloud infrastructure, network, server, operating system, storage, but the customer has control over the deployed application and possibly application hosting environment configuration. So that you read this part, compare with the previous software service, then you compare with the infrastructure as service, you will see the different. Infrastructure as a service, provision, processing, storage, networks, and other fundamental computing resources, where the customer is able to deploy and run arbitrary software, which can include the operating system and application. Even using this level infrastructure service, you still cannot. The customer does not manage or control underlying cloud infrastructure, but has control over operating system, storage, deployed application, and possible selected network components. For example, I give firewall, load balance. So in other words, back to here, in the infrastructure as service, you involve more control, deal with the hardware and other software, right? In the platform as service, you deal some the system-related issue, but not that much less than the infrastructure as service. In the software service, basically, we are custom is the custom use the cloud computing. You have not that much control for any hardware and software. Okay, let's move to next topic, is technology. Which technology support cloud computing? The first one is virtualization. In the past, computer hardware systems were designed to run a single application on a single operating system. I'm sure most students know it's VMware. This allowed for each application to get a significant amount of the system resource, but it also left this system underutilized. In other words, the server is not busy, not the people ask, the server just run idle there. So virtualized technology have become a standard in the world of computers. These technologies are software implementations of computer systems which partition hardware into high-level abstraction. So if you're interested, you can read some article. Means you can virtually divide the powerful CPU, or we say computer system capability to several small pieces. Each user can use one small piece. This allowed for resource sharing within the cloud, along with more affordable, flexible, and scalable hardware service. So it must have support by virtualization. Virtualization can be looked at as the abstraction of computer resource from the actual computer, which can successfully allow the databases, middleware, and operating system to particularly run anywhere. Middleware, I just add one few sentences here. The first time when we have internet, you have custom, you have and the servers between connection, right? I'm sure Dr. William mentioned a lot already, like the chapter 3 and chapter 4, that's really the middleware. Virtualization, the cloud computing paradigm allowed the workload to be deployed and scaled out quickly through the rapid provisioning of virtual machine or physical machine. So this word again, right, to deploy and scale out, scale in, that's a big characteristic of cloud computing. A cloud computing platform supports redundant, self-recurring, highly scalable programming models that allow the workload to recover from many inevitable hardware and software failure. This is another benefit, right? If one location service down, that can quickly through the cloud computing infrastructure use other locations hardware and software. This is the first technology, virtualization, very important. Service virtualization combine and slice business service deployed independent of the operating system, program language, or hosting location. The service may be off-premise cloud service. We mentioned that's as service, platform as service, infrastructure as service, or on-premise service deployed on a corporation data center. An intermediary cloud gateway sits between the producer and the consumer and aggregate the WSDLs based on policy enforced on the cloud gateway. Only authorized operation are exposed to the consumers. We will talk about that a little bit like operating system, but provide a lot of different functions in cloud computing. This picture gives a briefly, we can say is the idea, right? How virtualization works. From this picture, you can see the three parts. Left, cloud gateway, and the right service. Let's look at the consumer side, right? That divided is internal or external. That gives the requirement, what kind of service they require. How this request sent to the really cloud computer center to provide a service. It really through called the cloud gateway. What function it provide? Import cloud service, import data center service, aggregate service, publish and control service. So we will see in the next module a lot about cloud gateway, what kind of function they provide. On the right side, on-premise service incorporation data center, right? You have computer provider service. Also, you should have some place to store the data that just briefly give you an idea, right? That give the service ABC. Another one is called off-premise elastic service deployed in cloud that can provide the hardware service, software together. This just a brief picture show you how virtualization, this enabling technology make the cloud computing works. Second one is called hypervisor. Some people now change the hypervisor called the cloud computing operating system. Somebody still use hypervisor, right? People probably introduce a new name, but they provide the same function. From the functionality, the cloud computing provider, the idea doesn't have big change. When software is run on a virtual machine, the bit representing the programming instruction runs through a layer of software that simulates a dedicated server infrastructure. I think you see this, you caught this word already. This layer of software is known as the hypervisor. Hypervisor allows the servers to run a single instance of software that serves multiple clients at a time without needing to rewrite the software. Hypervisor also allows operating system and application to install a consistent hardware profile, although they oftentimes run a variety of active physical system implementation. So this sentence, I look a few articles already, right? It's hard. Some people merge this with the operating system. When we talk about the cloud computing operating system, you will see some operating systems that divided into a few parts for the cloud computing. So in here, I still keep a hypervisor is very important. It's a second enabled technology. This is a picture we draw according to we learned that time, right? We said, okay, you have client, right? That's customer. We require service. We have a virtual machine. Then this is the hypervisor put in the central. Then that's the related hardware and software. We ask the hypervisor provide more operating system function to satisfy the customer requirement. Virtualization aids in implementing a cloud computing system. The hypervisor is a layer of software that makes the virtualization process possible. Cloud computing has become a very popular paradigm because of the efficiency enabled by virtualization. Okay. We know that if we use cloud, we must use internet. That's the last enabled technology we discuss here. It's a web service. Without web service, no cloud computing. Okay. Web services today are frequently just an application programming interface or web programming interface that can be accessed over a network such as internet and execute on a remote system hosting the requested service. Example, we know all example, right? Google app, Google Doc, Google Site. Actually, we have more than this. So this is the third enabled technology, virtualization, hypervisor, web service. So this just briefly give you the idea, okay, what's the cloud, right? You know the Microsoft, Amazon, right? Yahoo, Zoho, all this. How we deploy the cloud. There are 4 deployment models we talk about. First, the private. The cloud infrastructure is operated solely for organization. It may be managed by the organization or third party and may exist on premise or off premise. Guarantee, right? I'm sure in the previous, you probably see the diagram already, such as bank. They have their own private cloud that make their system more secure. Second, community cloud. The cloud infrastructure is shared by several organizations and support a specific community that has shared concern. It may be managed by organization or third party and may exist on premise or off premise. I know the bank, they have their private cloud, or we can say it's community cloud because many different banks, for example, okay, Visa has its own private cloud, right? MasterCard maybe has its own private cloud. If, I'm not sure how they operate it, if MasterCard, Visa card, discover that put together form cloud computing. Maybe I call them, it is the community cloud, right? Public cloud. The cloud infrastructure is made available to the general public or large industry group and is owned by organization selling cloud service. Definitely, like NNT email, right? We use Gmail, it's managed by the Google. So definitely it is a public cloud. If we go to the Macy's or Berk shopping, we swap our credit card. I think in the store side, they use public cloud, but during the transaction, they need to go through the credit card, excuse me, credit card center. It should become the private cloud. So that's how we can divide it that. Hybrid cloud, the cloud infrastructure is a composition of two or more cloud, private, community, or public that remain unique entity but are bound together by standardized or proprietary technology that enable data and application portability. That's the example. We go to the shopping, we can think we use public cloud for the store, and when during the transaction, it goes through the hybrid cloud. So basically, this is the four very basic category. Okay, now we end the first module, Introduction to Cloud Computing.